So I think it's good evening in Lebanon, and welcome to this lecture. I'm going to be. My name is Arif Subhan. I'm the chief biomedical engineer at a hospital in Los Angeles here. My information is here. I was actually immediate past president of American College of Clinical Engineering, and also I'm on the adjunct faculty of University of Connecticut. I'll be talking briefly today about the current and best practices of clinical engineering in the United States. So I don't know how much or how different equipment you guys know about, that's out there. So this is just a selection of the different equipment that you see these days in hospitals, whether it's the anesthesia machine in the OR, surgical lights, surgical tables in the OR, to different types of monitors where you see those monitors either in a critical care area or maybe in an emergency department. Then you've got other devices like microscopes that are not just in the lab, but microscopes that are used in surgery in the OR. Infusion pumps is a staple equipment you see everywhere in the hospital. And then obviously you have got dedicated areas in the hospital like infusion clinics where you have patients receiving different types of infusion. Then different other areas including respiratory department or pulmonary department where you got the ventilators. And I think what this COVID last year has taught everybody is that there is a thing called ventilator. And we were talking about this big shortage of ventilators, you know in different parts of the world, just because there weren't enough ventilators. And later on they realized that they didn't really need as many ventilators. um, in fact, well, I don't have a picture of that device here. There's a device called the high flow oxygen therapy device, um, that's been found very useful actually, to mitigate some of the challenges of respiration with your COVID patients. Imaging is another big area where you got basic X-ray machines. I mean, this picture here is of a scanner. I'm not sure whether it's a CT scanner or an MRI scanner, but um, from basic X-ray machines, from portable X-ray machines to C-arms to fluoroscopic units to CT scanners, MRI, and then in the area of nuclear medicine, we have the PET scanners or PET CT scanners and gamma cameras. In the radiation oncology department, you see, linear accelerators and the like. SPS is another area, or surgical, supplies area where you got the sterilizers, where you are sterilizing different type of instruments that are used in the hospitals. EKG machines, as you all know, are used pretty much everywhere in the hospital. And they are in doctors' offices, like outpatient clinics, to main critical care areas, and also endoscopy equipment. There's a big trend, to doing all these endoscopic procedures. Okay, so as your professor said, we'll wait for the questions at the end. So let's just move on to the next slide. But if you have any questions, just note them down and you can ask them later on. So let's start off with the first slide, actually, what a clinical engineer is. And as I mentioned, I'm part of American College of Clinical Engineering. And we have actually, when I was president, I think the statistics was that about 14 or 15% of our membership actually was international. So I encourage those of you who have interest in clinical engineering to look at the website and consider becoming a member. It's not trying to sell ACCE, but it's a good organization to be part of, and we offer a lot of programs. And nowadays, with the COVID and everything, a lot of programs are offered online that are beneficial, to people all around the world. So way back in 1990 is when American College of Clinical Engineering started. In 92, they came up with this definition of a new profession. It wasn't really new, but they wanted to give it some kind of a boundary where a clinical engineer stood. They said he is obviously a professional, and there are two key words here: the one who supports, supporting some, and advancing patient care. Well, that's the key here that we do at the hospital. And we have two skills. Obviously, all of us are engineers, so we are applying our engineering skills. And then the other skill that is needed to run a clinical engineering or a biomedical engineering department, and there are different names to it. They call it sometimes the HTM, Health Technology Management Department. There's another organization I want to mention too, is AAMI, and you can go look at their website. They have a lot of programs as well. Anyway, so the point is that for a clinical engineer needs to have two skills. One is the engineering skill, obviously, because they're managing medical equipment, and then managerial skills because they're managing people, they're managing assets, they're managing equipment, they're managing money, because obviously maintaining this high tech, high cost equipment does require a lot of managerial skills. So that's what clinical engineer is, and there's a link there at the bottom. I encourage people to look at it, and some of the material actually I took in my presentation really is from that website. So I strongly encourage you to look at it, and there's some more information there too. So what does a clinical engineering engineer do? Now, this definition obviously varies from facility to facility, depending on the scope of the work, the equipment they have, how big the department is. And I was talking to your professor a little bit earlier. Our hospital is one of the larger hospitals, and we have a lot of programs which you don't find in typically other hospitals. One of the big things we do is teaching. We have a teaching program for our engineers. We have a teaching program for technicians. Basically, these are people who brought in after they finished the high school, not high school, I'm sorry, they finished the college, whether they're working like an associate degree or a bachelor's degree in engineering. And when they brought in, they're like go through some training program. So anyway, the work of a clinical engineer is a technology manager. Now, when we talk about technology, it could be any type of technology. As you know, the medical equipment encompasses a variety of technologies. So the knowledge of different technology is essential. Some of us, my background is electrical engineering as an undergraduate, but as you know, technology that is used in hospital is all over the map. I mean, there are aspects of excuse me, electrical engineering, electronic engineering, information technology, mechanical engineering, chemical engineering, you name it, it's there. If you look at the different types of instrument. And what we do as clinical engineers is assure that the medical equipment is safe and reliable. I mean, those are the key things. You do no harm is the basic theme. When you have a medical equipment, you don't want somebody to get injured or get wrong information. If somebody comes in for a diagnosis and you're using a medical equipment to measure his or her physiological parameters, you want to make sure that when the heart rate is shown on the display, the EKG that comes out, or a blood test or a urine test or whatever tests or a scan that comes out, it's reliable. It's giving you the right information based on the technology that is there. One of the other functions that clinical engineers do is they act as translators. That's a big, big thing which a lot of people, I think, miss or forget about. The reason I say this is because of the nature of the training that is provided to clinical engineers. We are kind of like, knowledgeable about not just about the engineering field that we are in, but we have knowledge about medical terminology, the medical procedures, the clinical procedures, not just the anatomy, physiology, but the understanding of how different devices are used and what information or what physiological parameter is measured, analyzed, etc. But also we have knowledge of information technology, and that's an area that if you don't have that knowledge, I strongly encourage to learn more about information technology. And I've grown up in the time when I finished college, my undergraduate, without using a computer. Nowadays you see 2 years old or 5 years old using computers. So things have changed. So information technology is key, and obviously business sense is important now. Obviously these organizations that we're part of, they have to make money. They have to be they're all, most of them are for non-profit, some are for profit, but at the same time they need some business sense. It's not like there's unlimited money to spend. You have to use the money wisely, find the best solutions. If you have a piece of equipment, how to best fix it, where to put in the resources, get the best contracts. So we'll talk about that in a second. So those are the three key areas. We act as translators when we work with clinical folks in the hospital, the doctors, the nurses, and you name it, the information technology people, and also the business side of the house. Then we talk about projects. We work a lot as clinical engineers with facilities department, the construction department, the planning department, and other clinical areas, whether it's nursing or other clinical areas, to help design new areas. It could be installing an X-ray machine, or it could be installing a CT scanner, or it could be installing a linear accelerator, it could be installing, a patient monitoring system. You name it. Whatever we do, we have to work with all these people in the hospital. So coordination, project management, very important, very essential for people in our business. And clinical engineers are the people who are best suited, because we have all this information, this knowledge about equipment, about the clinical side of the business house, information technology business, that makes us the most suitable for coordinating projects. And then, as I was mentioning, the last point here, the last slide here, the hyper tech world. We're living in a high tech world. We're managing and solving problems when we're connected, with networks. And we were just talking with your professor just a few minutes ago about cybersecurity issues. How accounts get hacked. How information that is communicated has to be kept secured. It's not just your bank account where you're logging into your bank account and drawing the money. This healthcare has its own sets of cyber security issues, network issues that need to be addressed. So our job is to assess, manage, and solve problems in this world that are not just healthcare technology problems, but problems in information, communication, and network systems. And as I mentioned earlier, our knowledge of financial and budget. So for example, you have a department that you are running in a hospital, you will have a fixed amount of budget, what resources you need in terms of people, money, equipment, budget to repair equipment, buy spare parts, bring in vendors to perform maintenance, repairs, etc. And do keep in mind that it's not just like your personal item, my television is not working or my refrigerator is not working. We've got devices there where the life of people are dependent on them. For example, your CT scanner, you may have only one CT scanner in the hospital, and then you need to get that fixed as soon as possible. What's the best way to fix it? In obviously a prudent manner, financially, but at the same time getting it fixed quickly. So where are you going to bring in the technical resources? What are you going to do if you need to bring in a part or purchase a part? And these parts, by the way, are not cheap. We're talking about, I'm going to talk in terms of dollars and cents here. Changing an X-ray tube, for example, or a CT scanner tube costs hundreds of thousands of dollars. So all that budget money has to be allocated and planned. The second item here, managing service contracts. So managing service contracts is another area that clinical engineers get involved with. The mere fact is that, it's not something that any in-house, when I say in-house, meaning people who are working in the hospital, can have the capability to work on a variety of equipment that is found in a large hospital. So they will have instances where they will have vendors, or it could be some third-party equipment service providers who would be managing the equipment, who would be actually fixing the equipment. And your job as the in-house department would be to manage those contracts. And those contracts could be simple contracts, where you could just bring them in on an as needed basis for maybe just repairs only, or just doing PMs only, or it could be a full service contract where everything is covered, including parts and, and also the coverage period, because some of those devices, as you know, they're not there for, use 1 hour a day. CT scanner in a large hospital, busy hospital, is used 24/7. So you may have to look at, coverage period longer than just the 8 hour day. It's not like somebody starts in the morning and finishes in the evening. Hospital is a 24/7 operation. Um, the third item coordinates maintenance activity. That's really, ongoing thing that goes on in the hospital, because you've got different types of maintenance activities. There could be just simple preventive maintenance, that's required by the manufacturer to, do regular maintenance on, which I call, just basic, making sure that, the maintenance gets done on your ventilators, your anesthesia machines, all equipment that requires maintenance. And then any corrective maintenance, that equipment that is broken or fails or it's not working and you need to troubleshoot and fix the problem. Managing medical equipment assets, I mean, that's a big, big thing. We're talking about, I was just telling your professor that I have about 10,000 different pieces of equipment. And you can imagine some are like small, tiny pieces, thermometers, monitors, maybe this size. And they're spread across multiple campuses, multiple buildings. And, they have legs, they have wheels on it. So they move from one area to the other, just making sure you find that piece of equipment when maintenance is needed, find equipment when you're doing the inventory of the equipment. It does turn out to be a lot of challenge. It's not like, you've got one person or half a dozen persons in the hospital. You've got hundreds and hundreds of people taking things around here, equipment attached to the patient, moving from one area of the hospital to another area of the hospital. Also, sometimes you have to move patients from, for example, our hospital or any hospital to another hospital because of a certain procedure that needs to be done or a level of care that needs to be provided. So in that case, the equipment moves with that patient. You've got monitors attached to the patient, infusion pumps attached to the patient, ventilators attached to the patient. So all those assets have to be managed properly, that, when you send the equipment there, when the patient reaches that other location, you bring your asset or equipment back. So all those things. Coordination of information technology. As you all know, medical equipment is not just working in isolation. It's not like a standalone device. It is based on a variety of equipment that supports it, like on the IT side. So you've got a bunch of networks, you've got servers and all that, storage of information, retrieving of information. So you're managing that. Also, you're managing projects. We talked about that. Regulatory compliance is another area that a lot of clinical or all of the clinical engineering people get involved with. You must have heard about JCI, Joint Commission International. We have Joint Commission here too. They have a bunch of standards, and if you have looked at their book, it's yay thick. For a variety of things, they have a bunch of standards for medical staff, for nursing, for information technology, for infection control, etc. But there are requirements for medical equipment too. And some of those requirements are just generic requirements, and they reference applicable national standards. For example, you may have heard about NFPA standards. So they would say, we refer all the details regards to this compliance to NFPA 99, which is one of the national standards for healthcare facilities. One of the other functions that the clinical engineer does is supervising in-house maintenance staff, which is really another aspect of maintenance, where you've got a bunch of staff who are technicians, who are engineers, who are working in the hospital, and you're making sure they're performing the right tasks or performing the right right projects and following through on projects and completing their tasks in a timely manner. So some more information here. I know it's a busier slide, but I'm just going to highlight on some of those bullet points which are like bolded here. One of the things that we do as clinical engineers is healthcare technology procurement and assessment. Now, it's just not, as simple. And I'll give you a very simple example. When you go to the store to buy a piece of furniture, you just make sure that when you bring in the furniture, that furniture will come inside your house or apartment. It fits the door. Same thing applies with medical technology, which is not as simple as buying a piece of furniture, because we're dealing with say, a CT scanner that may have 100 things to look for. You need to look at the power, you need to look at the air conditioning requirement, networking requirement, you need to look at the strength of the construction, you may need to build another room for it, you need to look at who's going to operate the machine, you need to find out what supplies are needed, what peripheral equipment is needed, how it's going to be connected to the network. So there are a variety of things that you have to look for when you make that decision of purchasing medical equipment. So those are the kind of things that you go through, and that's a topic by itself. I don't want to get in too much into it, but making a proper selection of the equipment is a key as part of a clinical engineer's job. And obviously, when he or she is involved in doing that, they're working very closely with the clinical and nursing side of the house. Because I always feel like, my example is that, hey, who has the equipment most of the time during the lifetime of the equipment? 90 to 95% of the time, the equipment is with the user. They are using it. It's with the technician or the engineer, maybe 5% of the life of the equipment. So they need to be comfortable. They need to know what the issues are, what challenges they are, how to use it, how often, there may be issues with it, etc., etc. There are like 50 different things you have to consider about that. And the second bullet item, evaluating new products. As you know, the field we are in, the biomedical engineering field, it is growing so rapidly because of the advances in technology. And whenever new product comes in, new technology comes in to measure a physiological parameter, or to better measure a physiological parameter, you need to make sure, you are evaluating that product to make sure that it's doing its job, and sometimes you have to do trials to make sure that, that's the product that you need. Sometimes you have to do work with the users to see whether the device is suitable for the organization or not. One of the things that they always consider is standardization. It's like infusion pumps. You can't have 10 different models, manufacturers of infusion pump in the hospital because of training issues, because nurses move from point A to B. They move the equipment from point A to B, say from ICU to OR. You can't have a different type of an infusion pump. So you need to have a standard infusion pump. And also, it helps you as biomeds or clinical engineers as you support and manage that piece of equipment. Product life cycle. This is a classic, what I should say is the basic function of a clinical engineer, if I can describe it. It's just like, when a baby is born to the time of death. Same thing with medical equipment. When you conceive this idea of having a new piece of equipment, and you're talking with your clinical folks, you're talking with the vendors to make a decision, okay, I'm going to buy this monitor, for example. From that point, that discussion, you're looking to buy, to the time is disposed of, meaning for after 5 years, 10 years, 7 years, whatever the lifespan is, you go through all those steps of evaluation, installations, incoming inspections, maintenance, repairs, recalls, you name it, training, and then, at the end of the life, you have to take that item off your inventory. It's just like, getting rid of old equipment. There's a process that has to be followed. Clinical engineers are really managing the whole product life cycle of the equipment. Training and education we talked about already in some ways, and training and education is essential because, as you know, each device is different. Each device has different maintenance requirements, training requirements. So so whenever we purchase equipment, we look for that for training and education from the vendors, both for the clinical folks because they will be the users, and then also for the technical people who will be fixing or managing that piece of equipment. And that's essential to make sure that the device is safe and effective for its use. Recalls and hazards, and this is another area. I mean, everybody knows about recalls. The cars you drive has a recall. The food products that are in the market have a recall. Same thing applies with medical equipment, and these medical equipment have a process of recall. We'll talk about that in a little bit more detail down a couple of slides, where you need to make sure that if that recall or that hazard that has been identified by the manufacturer has to be taken care of, addressed, you need to do that right away, depending on the nature of the recall. And sometimes, if there is a medical device incident, where a patient may get injured, patient may die, or there was a near miss, meaning that they were about to have an accident, but somebody was careful or it didn't happen. There has to be an investigation done to make sure that to find out what caused it, doing the root cause analysis. I'm sure you've heard the term RCA or root cause analysis, where you find out what caused the incident and what can be done to prevent it from happening in the future. Equipment utilization is another big area. What really it means is that, it's like you can't have 6 cars sitting outside in your garage or in the driveway, right? Same thing with equipment. You need to know when you are using equipment or purchasing equipment rather in the hospital, you have enough usage for the equipment, and that's that utilization. Because I don't know how it works in your hospitals there, but in U.S. hospitals, the one that operate in the private sector, they look for equipment utilization because with the time a patient spends, he or she spends in the hospital, they charge them, bill them for the time they were on ventilator, they were on anesthesia machine or patient monitor, etc., etc. So all those equipment, if they're just sitting there collecting dust in a storage area and not used, is a waste of capital resources. So clinical engineers play an important role in equipment utilization as well. And this is an area which is it can be sometimes very challenging too, because sometimes you don't need something and then suddenly there is a big rush for it to use those. Like, for example, we saw this big surge of ventilators or other equipment that was needed as part of the COVID. Equipment replacement planning, that's like, it's another important area where clinical engineers play an important role in. You don't wait till the equipment is about to die or it's about at the end of its life cycle, but you have a plan. Because we're talking about devices that cost tens of thousands of dollars. It's not like somebody has this big fat checkbook or a box of money in the hospital that they're going to go buy equipment worth whatever, 100,000 or millions of dollars. You have to plan. Okay, my anesthesia machines are getting old. They're like 7 years old or 5 years old, and in the next 2 to 3 years, I need to plan replacing them. So you need to have a plan for them. You have ventilators, you have other devices. So you have a broad spectrum of devices in the hospital. So which equipment is ready to be replaced, which equipment will be replaced in the next 2 years, 5 years, or 7 years down the road. So you have a plan. So it's not like you're waiting till the equipment is about to fail or it's failing multiple times. So which is I think a bad thing, because you don't want to be in a situation, you know, uh, where the equipment is failing and you are always trying to fix it, and the utilization of the equipment for patient care is not there. It's just like, having an old car. It's old, it has got many thousands of miles on it, it's failing, and every other day it fails, and it doesn't do the purpose of what you bought that car for, taking you from a place A to B. Instead of you being able to use the car, you end up using a taxi or some other means to go there. So that car is useless for you. So if you had planned, for example, okay, my car is getting old, obviously nobody has the money lying. So they need to plan, okay, in the next year or two, I need to replace the car. So I need to maybe save the money or get the money, whatever, and replace it. Same thing with equipment. And here we're talking not just about one device, we're talking about hundreds and thousands of devices, depending on the size of the hospital. And a plan is needed. A proper plan is needed. And sometimes, the technology changes too. You may have a newer equipment, but there's a better technology, a newer technology, a safer technology. So you just have to replace that piece of equipment. So all those things have to be done as part of a clinical engineer. Okay, so just to distinguish or clarify the different roles that biomedical equipment technicians play, BMETs, some of you may have heard it, so I'm just going to mention that here as well. These are the people who are really working hands-on, touching the equipment. Not that clinical engineers don't do it, but they are the people who are there installing, assembling systems, assembling networks, performing incoming inspections. They're performing repairs, which are sometimes referred to as corrective maintenance, doing regular maintenance, which is either called preventive maintenance or a planned maintenance, performing troubleshooting on equipment, doing calibration on equipment, and performing different type of testings, from mechanical testing to electrical safety testing and the like. All right, so there's some of the important aspects which I kind of touched on, and I'm going to go a little bit into detail. I know about equipment which I feel are essential. There are a lot of things that are out there, but I thought that there are some aspects which I want to go into more detail, because they're really the foundation of a good clinical engineering program. Now, this one, inventory control, is a challenge. It's actually not just a challenge, but it's also the foundation of any good program. If you don't know what you have, then there's a big problem. And as you said, it's not just your home or your closet with your clothes. It's a bunch of stuff. Equipment could be from any different source. It could be owned by the hospital, leased by the hospital, rented by the hospital. Sometimes you get loaner equipment, sometimes you get demonstration equipment, sometimes physicians bring their own equipment, sometimes patients even bring the equipment. So a good program knows where all the equipment is and what it is being used for. And there's a process to check all that equipment. The inventory needs to be current. Current really means that, somebody has gone there physically and touched that piece of equipment. They touched the equipment, it was there, and it's, and you can say by reassurance, okay, 6 months ago, 3 months ago, a year ago, we did find that piece of equipment, we did the maintenance on it, PM on it, or just did a physical inventory. And accurate too, meaning like, it should, if it says there are 100 infusion pumps in the hospital, there should be 100 infusion pumps, or it shouldn't be like this, oh, yeah, it says 100 infusion pumps on the inventory, but when we go look for them, we can only find 90 or 85 or 95, whatever. So it has to be accurate, it should show the exact number. So you know what you're doing, really. And as I mentioned earlier, recalls, alerts are attached to specific models, specific serial numbers, specific software. And you have to go find that piece of equipment and apply that recall. And if you don't know what you have and how accurate it is, forget it. It's not going to happen, And that's why I always feel like inventory control is the foundation of a clinical engineering program. Very difficult to do. It can be very boring, very tiring, but once you have a good, accurate inventory, current inventory, a lot of the problems that you may face are solved. A lot of the programs or aspects of the program can be managed well if you have a good inventory. Now, do keep in mind, things come in and go out. New equipment is coming, old equipment is being retired. And then obviously, as I say, examples where equipment moves across different areas of the hospital, different buildings of the hospital, between hospitals. So all those things have to be accounted for. Now, details are important too. It's not just saying, I'm just going to give an example. They're not just saying, here, this is a phone. What phone it is? Is it an Android phone? It's an LG phone, or it's an iPhone? What model it is? What's the serial number? What software version? Because all these things are going to help you further identify and help you better manage the piece of equipment. So that's very essential. And almost all the hospitals do have some kind of a computerized maintenance management system where they have a database file for each piece of equipment, where they list their control number, the manufacturer, the model, the serial number, location, version, etc., a bunch of stuff there, and that's a topic by itself. Incoming inspection is another area that is required by standards, and it's actually a very best practice to do. Because once you bring in a new piece of equipment, it doesn't have to be a new, it could be a loaner equipment, could be a rental equipment. Somebody in the hospital, a qualified person, a biomed, needs to do some kind of a performance verification and testing. What does that mean? Each piece of equipment is done out there here for either monitoring, treatment, or diagnosis of patients. I mean, if it's supposed to be an infusion pump, it's supposed to deliver X amount of fluid to the body, or if it's a defibrillator, they're supposed to deliver a shock of X joules to the patient. Or if it's a feeding pump, it's supposed to deliver, excuse me, fluid to a patient, a feeding to the patient. So that delivery of fluid, that information, that, like, for example, your EKG, heart rate, all that is displayed has to be accurate. Somebody is to verify that it's performing according to the specification. And some of you may have seen, there are a lot of simulators that we have for testing different types of devices. And they simulate, like, the heart, and you see whether it's giving an accurate information. And that's also always, within the tolerances of the specification, plus minus whatever the number is. Plus minus 1%, 2%, whatever the standards call for or the manufacturer calls for. Safety testing, obviously, very, very essential. It's electrical safety testing, making sure the ground wire resistance is correct, is within tolerance, leakage current testing. Also different mechanical testing from devices that are mechanically inclined, because you don't want the device to in any way harm the patient. And that has to be done before initial use. Before you're using it on the patient, make sure the device is really safe and accurate and providing reliable information. Also, when you do major repairs or upgrades to a device, you need to do some kind of a performance testing. It's not called incoming inspection at that time. It's called, performance verification and safety testing. Because when you open up a device, you may be making changes, upgrades, or replacing major components. You need to make sure after you put the piece together, you are testing the device to make sure that it's performing according to specifications. Okay. Planned maintenance. I mean, biomed technicians do spend a lot of time every day in the hospital doing maintenance on the types of devices, different types of devices that are there. And when we're talking about planned maintenance, we're talking about inspecting devices, cleaning devices, lubricating, adjusting, replacing sometimes non-durable parts, which includes filters, batteries, cables, bearing, gaskets, tubing, you name it, anything that's called for in the service manual. they do that. Also, as I mentioned, performance verification, that's that component where you're making sure that it's delivering the right output, measuring the right, um, excuse me, measuring the right rate, etc., and meeting the performance specification. Safety aspects we talked about earlier too, electrical safety, mechanical, and if it's a radiation emitting device, is the radiation that's coming out of the device, is it safe within the limits or not? There have been instances where, X-ray machines, if they're not calibrated properly, it doesn't happen nowadays, but it has happened where they were not calibrated properly, but were giving advertently high doses of radiation to patient. Here is a patient here who comes in to get his or her scan done, and everybody knows that when you're going through an X-ray, you get X amount of radiation dose. But if that radiation dose is higher than the one that's specified, so instead of doing good to the patient, they may be doing harm to the patient. So those are the kind of things that you're making sure that the device is safe, not just electrically or mechanically, but if it is, emitting X-rays or radiation, it is delivering the right amount of radiation and it's calibrated within the tolerances. Okay, equipment acquisition. This is a big area that clinical engineers are involved with for many months. I mean, it's not like something you sit in 5 minutes and make a decision. Okay, I'm going to buy a CT scanner, or I'm going to put in a patient monitoring system, or I'm going to buy 20 anesthesia machines. You need to come up with different, different things or processes along the way. And sometimes it could be additional equipment. So you may have to develop a needs assessment, like, okay, why do you need it? It could be a proposal from the clinical side of the house. How much it's going to cost? What's the financial and environmental aspect to it? And then you may have to submit a budget. It's not like, okay, I need this $1 million piece of equipment. Can I have the money? No, you may have to justify the budget, like saying, okay, why you need it? Like, okay, I'm going to need this $1 million piece of equipment because it does X, Y, and Z. And we're going to treat so many patients over so many years. It's going to cost us X amount of money. We may need a couple of people to operate the machine. We will need money to, manage or maintain that equipment. So a lot of those things have to be put under consideration. And then under the heading of selection, there are a bunch of bullet points there, and I'm going to kind of mention them briefly. It's a laundry list here, really, but the process has to be started where not everybody knows about everything that's out there, especially when new things are coming. So you do literature review to see what's out there, maybe what's going on in the literature people are using. Obviously, manufacturers are big sources of that information, getting information from vendors, and then you ask a proposal from the different vendors, basically asking them to, hey, I want to buy X, Y, and Z. Can you give us a proposal? And they will give you a proposal. Obviously, you don't go take a proposal from one vendor. You look at a couple of vendors and do some comparison, cost comparison, specification comparison, and all the different things that are needed for you. I mean, you don't go buy anything on the whim. Same thing with electric engineering testing, just to make sure when you're bringing in the device, this could be done or it could be relied on from other facilities. You may have a sister facility that has that particular device or that vendor, that device from that particular vendor, and you may use that. Contacting other users, just like when you're buying a car or buying a piece of equipment, you ask your friends and colleagues and saying, I'm going to go look for buying for a refrigerator or phone or whatever. What's your experience with this XYZ brand of refrigerator or a phone or whatever, or a car? And that's where you contact other clinical users in different hospitals or where that particular equipment is used and see what they think about it. They had that device for 3 years, 2 years. Are they happy or unhappy with the device? Because that's really the real test. A salesman can sell you anything, but the reality is that people who are using it, we may have a different opinion about it. So those are the kind of things that you look for. And then you ask the clinical people, you do the testing, trials, and you rank and stack the people. And then you do some negotiation saying, okay, we want to buy this, how much discount can you give, and etc., etc. So those kind of things that happen as part of it. And obviously, this is, I'm not in any way suggesting that clinical engineer is the only person who's going to be involved. We're going to be a major part of it, maybe the coordinator, but other folks from the clinical side of the house, the nursing side of the house, the engineering side of the house, facilities, planning, budget, logistics, other people will be involved in that, obviously. And then, implementation is where, you make a decision, okay, I want to go with XYZ, and then you issue a purchase order, go through the installation, acceptance testing, training. We talked about some of those things earlier too. And then you come up with a conclusion and start using the device. So it's a kind of an elaborate process. It takes months, depending on how the organizations are set up, how the budgets are. And it could be maybe a year, you plan something, as I said, equipment replacement planning. It's a long process. So it takes time, baby steps at a time, learning about the product. Sometimes it's easy if you're just adding equipment of the same model and type, then it's easy. I have 100 infusion pumps. I need to bring in 10 more or 20 more. And we're happy with the 100 we have. So just make a decision. Okay, we need more because of more patient load, or maybe open more beds, etc. And then we go forward with that. Okay, so that's that. Okay. Managing service contracts. As I mentioned to you, these devices are very sophisticated and complicated. They are not devices that anybody and everyone can go and fix. Obviously there are skilled people who can do it. Obviously the gold standard always relies on the manufacturer, especially for the newer devices, is to be able to fix those devices. Then we have other organizations, independent third-party organizations, which are referred to as ISOs. That's of people who have training on that piece of equipment, but usually don't cost as much as the original equipment manufacturer. And then third aspect is the in-house biomedical or clinical engineering department, which are your in-house programs, and they may have a skill set there or not, depending on, how big the program is, or how much training they have received. Now, these contracts could be just, as I mentioned earlier, probably could be just preventive maintenance only, could be repair only, and it could be, in some cases where you have a good biomedical engineering department, you could do the first call screening by the in-house biomedical department, and they can perform the repairs later on as well. So hazard recalls, we talked about that earlier. All these devices, they're, go through a process of testing and performance assurance, etc. But even with that, when these devices are used in the field, they may learn that there is a problem with the device that they did not suspect when they were doing the testing. And when they learn about it, here in the United States, there's an organization called FDA. It's a federal agency, Food and Drug Administration. And basically, they are required to notify them, and they are required also to propose either a correction or a removal, depending on the nature of the problem. So correction obviously is that the device is still there, but you would do a correction to it, maybe a software upgrade, maybe repairing that equipment that is subject to a recall, or replacing a component of that device. A removal obviously is the extreme where you feel like the problem is so severe that it has to be removed. It cannot be used on patients, so that has to be addressed by removing the equipment. And again, keep in mind, when it says here hazards and recall, does not always mean that you stop using the product or return it to the company. It has to be either checked, adjusted, or fixed. Because these hazards and recalls, do keep in mind, apply to implanted devices as well. I mean, everybody has heard about different implanted devices used in patients, whether they're artificial hip, They could be implantable pacemakers, implantable defibrillators, you name it, prosthetic grafts and, vascular grafts, etc. And sometimes they found out that, after X artificial heart valve, sometimes after a couple of years of use, they notice that there are failures that patients are getting, you know, affected by that device. So they may have to mitigate that risk depending on the nature of the problem. And that's another area where, it varies based on what type of device it is, what's the nature of the recall, what kind of problems can happen, and what can be done to remove it. Now, that's more for the implantable side of the house that BMS don't normally deal with. But on the equipment that is in the hospital, it could be as simple as going in and inspecting the device. They go there, okay, tell you to go look at this part, this module, and see if there are any problems. Because they noticed that this was a problem in 50 different equipment in different hospitals. But you may go there and find out that after inspecting that device and checking that particular module or for a particular subsystem, it's fine, no problem. So it's fine. If there's a problem, you go fix it. Then you need to repair it, maybe need to adjust it, or there may be an issue with particular feature or particular program within that device. In some cases, the device has to be destroyed because it cannot be fixed and it's danger to the patient. Sometimes you have to, if it's in a patient, then you have to notify the patient of the problem, and you need to monitoring the patient for any health issues, because sometimes if somebody has an artificial hip or a artificial valve or some things of that nature, it's not like, okay, go there, put your hand and remove the device. It's there with the patient, and depending on the problem, they may have to just notify the patient that, hey, there is a problem with your device, and these are the things that could happen, and if these things happen, you need to do XYZ, or they may have to upgrade their device, there may be some changes to the software, etc. So it could be a variety of things, but just do keep in mind, from our point of view, from the hazard recall standpoint of view, we've got devices that need to be addressed because of the risk that they pose to the patient. So that's recall or hazards. I just like people to understand it's no different than the recall that you get on toys, the recall that you get on cars, a recall that you get on a food product. There may be some contamination or bacteria in some food, a meat product, or cake or a pastry. Same thing with devices. And it's very, very essential that those devices are tracked and managed at the hospital. Otherwise, you wouldn't have a clue where those devices are, because you're dealing with a large variety of equipment spread all across the hospital, different buildings, etc. So just changing gears and kind of talking about some of the education opportunities and certification. I guess that's what I'm going to talk about probably in the next slide or two. Yeah. Okay, so the link is there. I'm not going to spend a lot of time talking about it. One of the programs that that offers clinical engineering education in the United States is through UConn. As I was mentioning to your professor earlier, we have a couple of students who come and spend 18 months or 21 months, depending on how their internship is set up, and basically their job really is, they're attending obviously classes, doing their coursework, taking the credit hours, or whatever. But all their learning and teaching and experience is in the hospital, dealing with day-to-day issues, working with other biomed personnel, other hospital personnel, administrators, nurses, technicians, you name it. And what they're doing is, as part of their training, given different projects, helping out senior engineers, helping out technicians to learn about the different equipment, how it's installed, and managed in the organization. And they also get exposure about the different hospital organizations, functions, different organization, have different organizational structure. But since you'll be working in a hospital, you get that exposure working as, in the hospital. So you get the real feel. It's not a lab where you're doing an experiment. but a real situation where you will be dealing with real people, real equipment, real patients, and obviously you are guided by your mentor or by the people who are supervising you, and you're assisting them in their work. So the details are there in the program. It's a program that is offered here in the United States, and as part of the training after completing, they get their master's degree and also um, a valuable internship experience. Um, the other thing that clinical engineers do, and that's promoted by American College of Clinical Engineering, is actually the certification. And okay, okay. So there's a link there, and you guys can go look at it. And it's a certification after, there's a lot of details to it. You have to have a bachelor's degree, 4 years experience, or 3 or 4 years experience, and there are different categories. If you have a master's, they accept it with less experience. But the bottom line is this last slide in my presentation, and I'm sorry, apologize that this is a um, very hard to read slide, but if you just read it, that those 8 bullet points, these are really the key areas where clinical engineers are tested in, and this is really the things that they um, they they do on a day-to-day basis, whether it's technology management, service delivery management, product development, information technology, education, facilities management, risk management, and general management. And if you look at some of the finer details or sub bullet points within each main heading, you're talking about things, for example, knowing about emergency power in the hospital, knowing about medical gas systems, knowing about building design, knowing about fire protection, knowing about workplace safety procedures, knowing about hazardous materials that are used in the hospital, knowledge of incidents and failures in the hospital, also learning about different IT and communications protocols, and doing a budget review. So all the things that we talked about earlier, from clinical system networking, interpretation of codes, managing staff, under the area of um, general management, where you're one of the big things that I do as part of my job is, recruitment, selection of staff for different positions, and and working with them to develop their skills, because it's not somebody you bring in and that person is trained and he or she knows everything and is going to work for the next 20 years or 30 years. No, you bring in a person, assess what skills he or she has, and then work with him or her depending on what area that person is going to specialize in, and develop their training program, help them with their learning and development of their skills. Some of it, as you can imagine, happen on the job, working on equipment, being supervised by senior technicians or senior engineers. Other cases, it could be by reading, learning, um, reading the service manual, reading the user manual, watching videos on websites, showing how different equipment is used, and then attending some courses, and some and obviously the on-job training and some manufacturer training. So it's a variety of things that you have to do to develop your skills, and it's an ongoing thing. It's not like, okay, I know everything after 3 years or 5 years of learning. It's a continuous thing, and as they say, if you don't learn, you don't grow. Basically, you just become stagnant.